In this lesson, we are going to learn the derivative of inverse trig functions. So there are 6 inverse trig functions: sine inverse, cosine inverse, tangent inverse, cotangent inverse, and secant inverse and cosecant inverse. And this is a notation for the inverse function. Of course, you can also write it as sine inverse of x. And the sine inverse for all these trig functions, the x value here are numbers, and the y value, the output, will be the angle, and most of the time we use angles in radians. So y is the angle in radians. So for all sine, cosine, all these 6 trig functions, in order for sine, cosine, tangent to have inverse trig, we limit the interval. So it's increasing or decreasing in that interval. And the most important thing for sine inverse, you look at the function sine inverse, tangent inverse, cosecant inverse of x. This will give us a value between negative pi over 2 to pi over 2, open or closed. For tangent, it's open, other two are closed. And for cosine inverse, cotangent inverse of x, and the secant inverse of x, this will give us a value between 0 and pi. Okay, so make sure when you evaluate the sine inverse, cosine inverse, it has to be inside this interval. You are not going to get 2 answers. There will be only 1 answer. Okay, this is the picture for these 6 trig inverse functions. And before we study the derivatives, let's have a look at how do we evaluate the inverse functions. And keep in mind, all these inverse functions will give us an angle in radians. And this is super important when we do the definite intervals. That will be super important when we plug the boundaries in. So let's have a look. Part A. So sine inverse of negative 1/2. So basically we are looking for sine of what give you negative 1/2. Because sine inverse give us an angle between negative pi over 2 to pi over 2. So it's 4th quadrant and the 1st quadrant. Negative, it has to be in the 4th quadrant with reference angle. A reference angle. Sine of what give you 1/2? 30 degrees, which is pi over 6. So for part A will be negative pi over 6. Cosine of B, cosine of what give you 0? This will give us an angle between 0 and pi, and cosine pi over 2 will be 0. Tangent of what give you radical 3? Tangent, arctangent, give us negative 90 to 90 degrees, negative pi over 2 to pi over 2. Tangent is positive, so it has to be in the 1st quadrant. Tangent, what give you square root of 3? Tangent, 60 degrees, which is pi over 3. And the sine inverse, so sine of what give you 0.3? We have to use our graphing calculator. So make sure your mode is in radians. Sine give us negative 90 to negative pi over 2 to pi over 2. So 1st quadrant, so the answer will be 0.3 radians. 305. Okay. However, if I ask you sine inverse negative 0.3, give us negative 0.305. Everybody, you can pause the video for 5 minutes and finish number 4 to number 18 and compare with my answers. You can compare your answer with my answer key now. Let me go over number 11. Number 11. Cosine of what give you negative 1/2? As we know, our cosine give us angle between 0 to pi. So between 0 to pi. In the 2nd quadrant, cosine will be negative. So cosine what give you 1/2? As we know, cosine pi over 3 give you 1/2. So with reference angle pi over 3, our final answer will be 2 pi over 3. And if you look at number 14 here, tangent of what give you negative radical 3. For tangent, it has to be in the fourth quadrant of first one, and it's negative, so it has to be here. With reference angle, pi over 3. So our final answer, negative pi over 3. And arc cosine 4. Cosine what give us 4? It's impossible because cosine is between negative 1 and positive 1. So it's D and E here. So these are the basic values of inverse trig functions. Next, we are going to introduce you the derivatives. So the derivative of the 6 inverse functions are given here by theorem 5.16. If you look at here, sine inverse, cosine inverse, and tangent inverse, secant inverse. So sine inverse and cosine inverse, they are opposite. Tangent inverse and cotangent inverse, there's a negative here. And the secant inverse and cosecant inverse, it's also opposite. So here is arc cosecant u. So the easiest case, when the inside function u here, if u is x only, so if u is x, all the u prime will be 1. So all the u prime in the numerator will be 1. So sine inverse of u give you u prime over 1 minus u squared. Tangent inverse of u is u prime divided by 1 plus u squared. And secant inverse is u prime absolute value of u times u squared minus 1. So sine inverse is 1 minus u squared, and secant inverse is derivative. This is the only derivative has absolute value here. Absolute value u squared minus 1. And for tangent inverse, the denominator is 1 plus u squared. Okay, everybody, you can pause the video for 3 minutes and try to finish problem A to E and compare with my answer key. This is the answer key for part A to part E. So for this type of problem, this is your u. You just plug in to the equation and take the derivative of u prime, u prime, u prime here, u prime here, and simplify it. And part E, after you simplify 1 minus x squared divided by square root of 1 minus x squared give us square root of 1 minus x squared. Any questions, please let me know. Next page, I list all the derivatives we learned so far. So this basic derivatives, the derivative, product rule, chain rule, and all these rules. Exponential logarithm functions, different base than other than e. Sine, cosine, tangent, basic derivatives, and this is what we learned today. The homework is right here.